present our research with my supervisor, Mr. Alrizal, about the impact of phase transition to the neutron star property. We know that the existence of hyperon in the core of neutron stars will affect the global properties of neutron stars, like mass, radius, structure, composition, etc. And this work has done before by Jorgen Tuckner-Billig et al. They got a neutron star with a small radius about 8 kilometers, which indicate the existence of hyperon stars. It means the path dominated by Hyperons. In this study, we revisit again their work, but by using different parameter sets, and we assume the pressure in the neutron star is anisotropic, which means there is a difference between radial and tangential pressure. As you see the phase transition in neutron star, we will vary the G sigma star lambda coupling constant. We begin with the equation of state of neutron star. This is very important one because this is one essential input to determine the properties of neutron stars, and we use a relativistic mean-field model with the total Lagrangian consists of Lagrangian baryon, meson, interaction, linear and non-linear, and electrons. For the case anisotropic pressure, we use Doneva and Yazevic model with the anisotropic factor is lambda 2m divided by r. Okay, we begin with the relation between pressure and energy density. We can see here there are three types of variation value. No sigma star and p, and then 0.775 and 1. You can see from the black graph, it's a linear graph. There is no indicate there is no phase transition. When we increase, become 0.775 for the red graph. You can see the graph will be branched at a certain point around this point, which indicates the phase transition from neutron to hyperon method. And then, if we increase again, become 1, we can see will appear second minimum, which indicates the stability of method. This result is different with Jorgen Tuckner-Billig result. The significant difference happens to the variation value of 1. We can see for their result, the phase transition occurs around the value of pressure and energy density close to 0. Meanwhile, our result, the phase transition occurs around this point. And then the relation between bending energy and saturation density. We also can see for the variation value 1 will appear second minimum, which indicates the stability of matter. And then this is a relation between fraction and saturation density to show the dominant particle that contributes to the phase transition. We can see for the variation value 0.775, the sigma hyperon is here, and also for the 1. So we can conclude that the dominant particle that contributes for phase transition is sigma hyperon. And then for the relation between mass and radius, this is for the case isotropic pressure. We get the maximum mass is 1.69 mass of ton, and radius 11.56. And then for the variation 0.775, we got the maximum mass is 1.53. And then for the variation value 1, we get the maximum mass 1.52, and the radius is 12.74. This is for the case of anisotropic pressure. We get the maximum mass is 2 times mass of sun with radius is 11.19, and then for the 0.7 we got maximum mass 1.92, and then the last one we got maximum mass 1.64. So the conclusion is we can see the equation of state of neutron star is very sensitive to the G sigma star lambda divided by G sigma n Hawking constant variation. And then for the case anisotropic and isotropic, we can see the similar trend, but for the isotropic pressure we got a smaller mass, and we cannot find the star, the Hyperon star like Jorgensen result. Thank you.
So 1.44, this is for the case of isotropic pressure.
This is for the isotropic pressure.
So go back to standard pressure. So just a regular.
So this is to show that the maximum mass is 1.53, but in this point the star become unstable, and then stable again for the mass 1.44 mass of sun.
No question. Can you tell me again the Lagrange equation for
Lagrange? Yes, this one.
Yes. We can explain again what term.
Okay. We use a relativistic mean field model. Yes. The total Lagrangian consists of the Lagrangian baryon, this baryon, and this is Lagrangian Freemason. It consists of like sigma meson, omega meson, or rho meson, and others. And this is a linear interaction, yeah, a Lagrangian interaction which consists of linear and non-linear. And this is for the Lagrangian of lepton. I don't show all of the calculation for there is
Okay, the same time is up. Let's stop.